Our second lesson on section 1.3 is on intercepts. So intercepts continue with our linear model. And the intercept is where the linear model, or just for short, we'll call it a line, and an axis intersect. There are two types of intercepts. There are x-intercepts and y-intercepts. The x-intercept we'll discuss the first. The x-intercept is a point where a line crosses an x-axis, and it's a point where the y-coordinate is 0. So what you see over here on the left, I've drawn a graph, and I have the y-axis here and the x-axis here. Their intersection, of course, is at 0. And this is the x-intercept right here. This is where this red line, or this pink line, is crossing the x-axis. And you'll notice how the ordered pair that represents that point of cross has an x-coordinate and its y-coordinate is 0. The x-intercepts look like the a equals a was whatever the x value is, and the 0 is the y value. The y-intercept is a point where the line crosses the y-axis, and it's the point where the x-coordinate is 0. So here on my little graph, I've shown you where it crosses the y-axis, and I've drawn in the ordered pair here. The ordered pair is x equals 0 and y equals 6. You'll notice if you count 1, 2, 3, 4, 5, and that's at 6. So the x-coordinate is 0 because this is 0 for the x right here. So this is x equals 0, and then 1, 2, 3, 4, 5, and then 6 up on the y, and that's how I'm getting those numbers. Now the y-intercepts look like 0b. We always use b to abbreviate or to indicate that we are talking about a y-intercept. That is a across-the-board commonality. If you want to know why, you can Google it and you'll find out the answer on that. When I ask for an intercept on paper at any point in time, I do want you to give me an ordered pair. By the way, I abbreviate ordered pairs as OPs. And the books usually are going to give you just a coordinate. So if they say x-intercept, they'll just say the x-intercept's 4 here. And if they say the y-intercept, they'll just say the y-intercept is 6. But I want you to get in the habit of giving me ordered pairs, please. Now, to further exhibit our points and to illustrate the fact that we have interpretation for x and y intercepts, an x-intercept being interpreted as the amount of input that is available when there is 0 output or no output, and the y-intercept being what we call in a lot of linear models a baseline, or the amount of output available or being given when 0 input is present. So we are going to look at again example number 17 or 16 on page 31 to do some interpretation. So back to our problem, we remember we had the amount of money after so many months in a savings account. So part C we're going to start with here. It says, what is the intercept of the model? So we're asking for the independent intercept, the y-intercept in other words. So we see here that it is where it is 3,000. So here I would draw in 3,000. So you see I've set it up so it's 0, 3,000. But we want to interpret what that means. So the meaning is that there is $3,000 when the account was opened. In other words, when it's 0 months, that's when it was opened, there was $3,000 in the account. Now part D wants to know about our independent intercept, our t-intercept, the number of months. So this one where it intercepts is at 6. So I'm going to go over here, and for my intercept I'm going to put in a 6. What this means is that after 6 months there will be a 0 balance, and that's the interpretation. Now when the book answers these questions, they are only giving you a number with units. So they're saying $3,000 when the number of months is 0, and 6 months when there's a $0. But on paper, what I want you to get in the habit of doing is just giving me both those ordered pairs. See the abbreviation down here of OP, both ordered pairs and the interpretation. It's just a better habit to get into on paper. But when you do things on Course Compass, you may not end up doing it that way. So that concludes our introduction to intercepts and a little example there.